we are covering the chapter Indices. Have you ever heard of the term exponential growth? It signifies manifold increase, an increase which happens really fast and it keeps increasing as the base on which it is calculated becomes larger and larger. Let me explain with an example. If you have $2 on the first day of a month and every day you double your earnings, do you have any idea? Can you just make a wild guess? How much will you have at the end of a month of 30 days? Incredible as it may sound, you will be a billionaire. You will have $1,073,741,824. That is 1,073,741,824. Welcome to the world of exponents or indices. In our example, we had to multiply 2 by itself 30 times, as every day the earnings were doubling. This means that we have to carry out the operation 2 into 2 into 2 into 2 into 2 30 times. When a number or variable is multiplied by itself multiple times, we can save the drudgery of writing the number over and over again by use of index notation. In index notation, a to the power of m, a is the base and m is the power or index or exponent. Index is written in smaller size above and to the right of the base. So, the index m here signifies that the term a is multiplied by itself m times. So, you can see the power of the power m, pun intended. Indices is the plural of index. It's pertinent to note that index applies only to the base to which it is attached. For example, in AB square, only B is squared. I will now state and explain laws of indices. Laws of indices enable us to carry out various operations with indices and give the answer in the form of indices itself. There are 8 laws of indices. I will now state and provide proof and explanation for each and every law. First law of indices deals with multiplication. A to the power of m into a to the power of n is equal to a to the power of m plus n. Here's the explanation. Let's take an example of 2 to the power of 4 into 2 to the power of 3. 2 to the power of 4 signifies 2 into 2 into 2 into 2 and 2 to the power of 3 signifies 2 into 2 into 2. In effect, we are multiplying 2 by itself 7 times. So, 2 to the power of 4 into 2 to the power of 3 is equal to 2 to the power of 4 plus 3 is equal to 2 to the power of 7. You will notice that we added 4 and 3 and got 7. Hence, a to the power of m into a to the power of n is equal to a to the power of m plus n. Second law of indices deals with division. Explanation. Let's divide 2 to the power of 7 by 2 to the power of 4, which will be equal to 2 into 2 into 2 into 2 into 2 into 2 into 2 divided by 2 into 2 into 2 into 2. So, we cancel out 4 2's from numerator and denominator to get 2 to the power of 3 as the final answer. You will realize that from 7 2's we have taken out 4 2's. This is a concept of subtraction. Hence, a to the power of m upon a to the power of n is equal to a to the power of m minus n. Third law of indices deals with power of power. A to the power of m whole to the power of n is equal to a to the power of mn. Explanation. Let's study the example 2 to the power of 4 whole to the power of 3. Treating 2 to the power of 4 as a term, we can write 2 to the power of 4 to the power of 3 as 2 to the power of 4 into 2 to the power of 4 into 2 to the power of 4. Using the first law of indices, we get this equal to 2 to the power of 4 plus 4 plus 4. Now adding 3 sets of 4 is a concept of multiplication because 4 plus 4 plus 4 is equal to 4 into 3. So 2 to the power of 4 whole to the power of 3 is equal to 2 to the power of 4 into 3 is equal to 2 to the power of 12. So we can say that a to the power of m whole to the power of n is equal to a to the power of mn. Fourth law of indices deals with zero index. A to the power of 0 is equal to 1. Here's the explanation. Let's consider any general term as a to the power of m. When we divide it by itself, we get 1 as the answer. So a to the power of m upon a to the power of m is equal to 1. Now let's apply the laws of indices to solve a to the power of m upon a to the power of m. Using the second law, we get it as equal to a to the power of m minus m is equal to a to the power of 0. But the same expression a to the power of m upon a to the power of m was also equal to 1. Hence, a to the power of 0 is equal to 1. Fifth law of indices deals with negative index. It tells us how to get rid of the negative sign in index. Explanation. Let's solve a to the power of m into a to the power of minus m. Using the first law of indices, we get it as equal to a to the power of m plus minus m is equal to a to the power of 0 is equal to 1. So, a to the power of m into a to the power of minus m is equal to 1. We can use this expression to find a to the power of minus m as equal to 1 upon a to the power of m and a to the power of m is equal to 1 upon a to the power of minus m. Let me offer a Vinmantra for the fifth law of indices. Flip the base upside down and negate the power. In 4 upon 5 to the power of minus 2, 4 upon 5 is the base. So we flip it upside down, thereby getting 5 upon 4. Then we negate minus 2 to get 2. So the final answer becomes 5 square upon 4 square is equal to 25 upon 16. Sixth law of indices deals with fractional indices. Nth root of a is equal to a to the power of 1 upon n. Explanation. 3 into 3 into 3 into 3 is 81. Since 3 when multiplied by itself 4 times gives 81, so we write fourth root of 81 as 3. Now let's consider a to the power of 1 upon 4 into a to the power of 1 upon 4 into a to the power of 1 upon 4 into a to the power of 1 upon 4. Using the first law of indices, we get a to the power of 1 upon 4 plus 1 upon 4 plus 1 upon 4 plus 1 upon 4 is equal to a to the power of 1 is equal to a. Since a to the power of 1 upon 4 when multiplied by itself 4 times gives a, so we can say that fourth root of a is a to the power of 1 upon 4. Hence we can say that nth root of a is equal to a to the power of 1 upon n. Now let's compute 32 to the power of 3 upon 5 using laws of indices. In these type of questions, you will be in a position to express the base in a manner so that later we will be able to cancel out the denominator of the fraction. Here 32 can be replaced by 2 to the power of 5. So using the third law of indices, we can express it as 2 to the power of 5 into 3 upon 5 is equal to 2 to the power of 3 is equal to 8. Seventh and eighth law of indices are more like words of caution. Seventh law states 8b whole to the power of m is equal to a to the power of m into b to the power of m. And eighth law states that a upon b to the power of m is equal to a to the power of m upon b to the power of m. The seventh and the eighth laws of indices are inspired by the careless mistake students often make. They write 2x whole to the power of 3 as 2x to the power of 3, which is wrong. The correct answer is 8x to the power of 3. Similarly, they write x upon 3 the whole square as x square upon 3, which is wrong. The correct answer is x square upon 9. I want to highlight another careless mistake which students often commit. They simplify 16x to the power of 16 the whole to the power of 1 upon 4 as 4x to the power of 4. Because they see 16 and 16 as the same number, so they write 4 and 4 as the same number. But this is wrong. Steps to get the correct answer are as follows. Using the seventh law of indices, we get 16 to the power of 1 upon 4 into x to the power of 16 whole to the power of 1 upon 4 is equal to 2 to the power of 4 into 1 upon 4 into x to the power of 16 upon 4. This gives the final answer as 2 into x to the power of 4. This brings us to the Vinmantra. Numbers and variables behave differently. Hence, you have to treat them differently. Here's a Vinmantra to solve exponential equations when bases are different. Equate the bases in order to equate the powers. Let's use this Vinmantra to solve an application question which has appeared in IGCSE board May 2016, paper 42, question 2a. We have to find the value of x in all these sub questions. 3 to the power of x is equal to 243. Since 243 is equal to 3 to the power of 5, so x is equal to 5. 16 to the power of x is equal to 4. Let's equate the bases. Since 16 is equal to 4 square, we get 4 to the power of 2x is equal to 4 to the power of 1. So, 2x is equal to 1 or x is equal to half. 8 to the power of x is equal to 32. We express 8 and 32 as 2 to the power of 3 and 2 to the power of 5. So, 2 to the power of 3x is equal to 2 to the power of 5. This gives 3x is equal to 5. So, x is equal to 5 upon 3. 27 to the power of x is equal to 1 upon 9. We express 27 and 9 as 3 to the power of 3 and 3 square. So, 3 to the power of 3x is equal to 1 upon 3 square. Then, we flip the base upside down and negate 2 to get 3 to the power of minus 2. So, 3x is equal to minus 2 This gives x as minus 2 upon 3.